So to this point, we've been talking about handling data and how we can use collections of data, how we can process collections of data, and that's all worked out pretty well so far. But what happens when you start to deal with very large collections of data? Because let's be honest, in the real world, in a lot of applications and a lot of businesses, you're dealing with very large amounts of data, large collections of data. And we are always, as developers, we are always limited by the platforms and the systems and the hardware that we're running on. So you can oftentimes run into issues and problems when you start to process large amounts of data because you tend to run out of disk space or run out of memory or things like that. So we always have to be cognizant of how we're handling those scenarios where we're dealing with very large amounts of data. So let's work on an example and let me show you how you can solve it in a Python sort of way. So let's use a very common example. Let's talk about the Fibonacci sequence. Now, if you're not familiar with Fibonacci, it's basically the concept of you start with two ones and then you add those two together and you get 2. So the first three numbers in the Fibonacci sequence are 1, 1, and 2. And then as you move along, you add together the last two numbers to get the next one. So it would look like 1 and 1 is the beginning, and then you add 1 and 1 together, you get 2. And then you add 1 and 2 together, you get 3, add 2 and 3 together, you get 5, 8, 13, so on and so forth. And this is one of those infinite sequences. Like it never ends, it continues to go on as long as we're dealing with numbers. So let's write a simple function that is going to take in how many numbers of the Fibonacci sequence you want to figure out, and then it will process and return a result. So let's go ahead and define a function. We'll call it Fibon, or however you would like to call it, and it's going to take in a value n. So that's going to be how many numbers of the Fibonacci sequence we want to find. So it could take in whatever number you'd like, well, some integer value. So in order to solve this, we're going to deal with two variables. We'll say a and b, and they're both going to be equal to 1. So that's where we're going to start. That's where we're going to get those two first ones. And then what I want to do is I want to have a loop, and I want to say for some value I in the range up to n, or it could be n plus 1, depending on if you want it to be inclusive or exclusive. It doesn't really matter for this example, but let's just keep it simple for this. And then every time it does that, we're going to need a result here. So let's say the result is going to be some sort of list. So then what I want to do is I want to go into result and I want to append to that result. I want to append A. And then after I do that, I want to modify A and B. So A and B are now going to be equal to, A is going to be equal to B, and B is going to be equal to A plus B. And then once that's all done, we're simply going to return our result. So it's not a very complicated function here. It's pretty simple. So let's go ahead and give this a test. So what I'd like to do is I would like to just do a simple print, and I want to print out the result of my Fibonacci function. Let's do the first 10. So let's go ahead and save that. We'll pop over to our console here, and let's go ahead and run that. So there you go. We have 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and those are correct, and everything seems to work just fine. And let's go ahead and, maybe up our game a little bit. Let's do 50. Let's save that. So let's do the first 50. Okay, that's pretty good. As you can see, the numbers get fairly large fairly quickly. Okay, well, 50 is pretty good. How about 100? So let's save that. Let's run that guy. All right, we're getting a little bit bigger. Well, let's get a little bit crazier, and let's say that's 100, that's 1,000, 10,000, 100,000. Let's do the first 100,000. So let's clear our screen here, and let's go ahead and run this. And you're going to see this is going to start to take quite a lot of time. And depending on the resources, the amount of memory that you have on your system, this could take an awfully long time. And worst case, you could actually run out of memory, and this might never finish. And that's a big problem, is how can we get around this limit of running into this problem where we're trying to run a particular function or deal with a lot of data or store a lot of data or do something with these collections that just become too big to be able to contain all of it in memory at the same time. So let's go ahead and stop this now, and we'll clear it out. How can we fix this? Well, in the world of Python, we have this concept of a generator. So what's a generator? Well, a generator is a function that instead of having a return value, uses the yield keyword. So the yield keyword, what exactly is that? Well, the yield is going to present or be the next value that gets processed within a collection of data that we're dealing with. So a generator is going to create an iterator that is something similar to a collection that you process one value at a time. So there's a special function called next that is part of an iterator that it will call one at a time, some value.next. And instead of trying to store everything in memory at the same time, it's only going to process the next value, the next value, the next value. So you obviously can't just do a print like this, and I'll show you that in this example. You're going to have to use the resulting generator, the resulting results of that generator in a for loop to actually get through all the values. But I'll show you how that's going to work. So let's create a slightly different function here. We're going to do _g for generator, but it's going to be pretty much the same. We're going to start out the same way. We're going to have these two variables, a and b. They're both going to start off as 1. We're not going to store a result because in this point we don't need to store anything, but we'll say for I in range, once again, up to n. And at this point, instead of appending something to a resulting list or something like that, we are actually going to use the yield keyword, and we're going to yield a. Then, once we've yielded a, we'll go ahead and do our A-B processing, just like we did before, a equal to b and b equal to a plus b, and then we're done. So like I said, when we're talking about a generator is really just a function that yields a value, an individual value, in this case a, instead of doing all of the processing and storing everything in a single result list and then trying to return that. So now, if I were to try to do the same thing and use that generator function instead, let's go ahead and save this. Let's go ahead and run this again. You're going to see it processes instantaneously, even though I've said process the first 100,000 in the Fibonacci sequence. I got a result immediately, but as you can see, I got a generator object. So a generator object is an iterable collection in and of itself. So if I try to print it out, it's just going to give me the fact that, hey, this is an object at this location in memory. So if I actually want to do something with this, then I'm going to need to actually print out each individual value. So let's modify this just a little bit. We'll say for x in, and then we're going to create or use this function call like this, paste. So we're going to say for that, because this function is going to return an object that is iterable. So then each time through, like I said, there's a special function attached to this, which is going to be called next. So the equivalent would be saying x.next like this to get the next value, and then printing out whatever value returns from that. But when you process it as an iterable value like this, like some sort of collection, you don't have to use the next keyword. I could simply say, give me x. So let's go ahead and save that. So now, if you recall, but just to show you that it still works the same way, let's start off with 10 again. Let's go ahead and save that. Let's process 10 of these. And you see, we still get the same answer, 1, 1, 2, 3, all the way up to 55. So then if I were to modify this to be 100, let's save that and run it again. I get the first 100, and it was done pretty much instantaneously. And if I really wanted to get crazy again, that's 100,000, 10,000, 100,000. If I wanted to do 100,000, remember last time it just locked up and waited. Now this is not going to lock up. This is not going to lock up and wait. It's going to process. But as you can see here, it's go ahead and processing each individual number at a time and not working to store them all in a list and constrain them all and try to put them all into memory at the same time. It's just going to process each individual value as it goes. And this is going to sit here and keep returning extremely large numbers for as long as I'm going to let it go until it finishes. But I'm going to stop it right here just to show you that you can process very large and even infinite numbers of values using generators within Python, because like I said, it's not trying to do and process all of this stuff in one list all at the same time by storing it all in memory. It's going to yield individual results, just like this, and process them each one at a time using the next method or next function on the object that comes out. But like I said, in the world of collections, you don't have to specify next in this case if you are using it or iterating it through in a loop such as this, but now you can process incredibly large numbers of data without having to worry about running out of memory.